Hey everyone, so let's talk about arithmetic operations. This is important when we do code at all. You can perform arithmetic operations using variables and constants. I'm going to go ahead for now and jump into some code and discuss how we do that. So here's a code window, and I'm just going to go ahead and code a new class called Arithmetic Operations. Well, let's just call it Arithmetic. Let's make it easy. Arithmetic. Okay, cool. And once again, I didn't put the Java keyword. We're going to close this out without saving it. And I'm going to put in the Java extension, I should say. Go ahead and code this .java. There we go. And I'm going to save that and let's do some code. So public class arithmetic, public static void main, string args. How many times am I going to make that same mistake? It needs to be capitalized. It's a reference class. Square brackets, args. And I am going to declare some variables. It's important this is commented out. All right. So when I do that, I'm going to go ahead and create a num. And then I am going to say, we'll just go ahead and declare initialize it in the same line. All right, so num equals 5. And what I'm going to do is I'm going to print num divided by 2. And what you will see at this point, it's going to do the division first, then it's going to, I'll go make this a print line command. It's going to do the division first, then it's going to run the print command. But what you're going to see is you're going to see what the answer is. And I did not expect that to already be compiled, but it somehow was. Either way, sorry. Still gonna get the same answer. I don't know. This is an interesting case because it looks like it ran the program already without it being compiled, and I don't know how that even happened, but it doesn't matter right now. I'll figure that out later. But what I want you to notice is when I divide an integer by an integer, I get an integer. I don't get a decimal. An easy fix for that, if you want a decimal, is make one of these a double by putting a period at the end. That now makes that a double. I'm going to save that program. I'm going to do that. I'm going to run the program, and you can now see it's a double. So it's just a simple fix. But remember that integer division starts with an integer and ends with an integer. So 5 divided by 2 will be 2. 16 divided by 3 will be 5. Integer division returns an integer. It eliminates the decimal. Okay, so that's how that works. When you do an integer division, the integer part is maintained, the fractional part is lost. Okay, and that's what that looks like. There's 5 different operators. Remember, modulo is the remainder. So if 16 mod 3 is going to return a 1 because there's 1 left over when you do 16 divided by 3, it's going to equal 5, remainder 1. And so just remember that modulo is the remainder operator. All right, operator precedence is important. We multiply and divide before we add and subtract. And modulo falls within multiplication and division operator precedence. So yeah, so let's just clarify in code the associativity and precedence. Remember that the rules include multiplication, division, and modulus first, then addition or subtraction. Let's step into some code and look at what I'm talking about. So here we have that arithmetic, And I'm going to go ahead and do something like 5 times 3 plus 4 times 2. And of course, if I did this left to right, I'd have 15 plus 4 is 19 times 2 is 38. But what really is happening is I get 15 times 8, and I should get 90. All right, so I'm going to go ahead and save this, and we're just going to go ahead and see what happens. All right, I don't know what I just did right there. I got 23 because 5 times 3 is 15, and 4 times 2 is 8. I did multiplication earlier instead of addition. So this is 15, and that's 8. If I do, there's really no way to make this happen a different way, but yeah, you can see how the precedence works. We multiply first, and then we add. I don't know why I said 90 earlier, but in any case, 8 and 15, when you add those together, is 23. But what I want us to understand is something that people sometimes forget. Let's say I have some string concatenation. So hello, uh, or let's say it this way. You now have num plus 2 numbers. People will assume that this works the same way, that num plus 2 is going to happen first, and then the rest of the statement is going to happen. But that's not really what happens. In fact, the order of operations happens, so the string concatenates, you now have plus 5, and then it concatenates again, and then it adds a final string. All right, so I'm going to show you what that looks like here. I'm going to run this, and you say you now have 52 numbers because I concatenated these as strings. In this case, because the order of operations is left to right, I want to go ahead and put the numerical stuff happening first, to set this order first as a parenthesis or a grouping. Now I can run this, and it's going to run more normally when I save this correctly. All right, I'm going to run this more normally, and you will see what will happen. That's what we expected, and that's a better run of what we're looking for. An important thing to note when you're coding is making sure that your arithmetic statements are not happening inefficiently. So in this case, we have a state withholding and a federal withholding, right? But we can actually do it better by doing gross pay as a separate value, where hours times rate is set up as its own variable. Kind of look at any redundancy and figure out if you can abstract the variables better. And finally, know that imprecision of decimals leads to problems in the math. If you get something you don't expect or want, it might be a double or float error. And that's kind of what you need to know at this point about arithmetic operations.